learners. Welcome to Triaright. Today, moving further in Java, we will be learning about the Fibonacci series using the functional interface. In this Fibonacci series, we know that Fibonacci series is the series of numbers in which the third number is the summation of first two numbers, and respectively on further the third number will be the summation of first two numbers before two numbers. So here is the functional interface. At the data functional interface, we can see that there is an interface by the name of at the rate of functional interface, and the interface Fibonacci generator is having a method integer generator int generate is having a data value of int data members as int, and we are passing the parameters as int n. We are passing the parameter as int n. Now following that, we have the class named as Fibonacci class, public class Fibonacci using functional interface. And moving further, we have the public static void main string args, which is the main line of Java main function, main method line. And then we have the functional interface. Then we have the interface where we have the lambda expression. Then we have where this is the Fibonacci is of the type Fibonacci generator only, and here the functional interface here we will be passing the parameters, and this parameter will represent in the curly braces, that is the body part. Inside the curly brace we will be passing the body part. So in the body part we have, if the n value of n is less than 1, it will again go to the n point, start is entering the point of n. That is, again we have to enter the n until and unless the value of n is greater than 1, it can't be true. So here we have the first value as 0, first value of a is 0 and b is 1. So a is 0 and b is 1. Then we are following a for loop. Then we are coming to a for loop where we will be initializing I is equal to 2 and I less than 1 and I plus plus. By this line we are generating a loop. Here comes the body part. Here comes the body part inside the loop, and we have the temp variable. This is the temp variable, which is summation of a and b. After the summation of a and b, the value will be assigned to temp variable only. And after following the temp after doing the summation, a value will be assigned by b value, and b value will be again assigned by the temp value. Means the summation of summation of a and b will go to the temp, and b value will be assigned to a, b value will be assigned to a, and b value will be assigned to by the temp. Yeah. So after summation, the third number will be summation of first two numbers 0 1, then it will be 1 again, and the value of 0 will be assigned to by 1, and 1 will be again assigned by 1. And so here the returning value will be b, which is the temp variable, which is the summation of variable, summation of a and b, which is the temp variable. So the temp variable will be again returned, that is named by the b only. So coming on to this, we have the Fibonacci number. We have the Fibonacci number as we have the first Fibonacci number, and we have the loop. Here there is a loop, and in the loop we have the n value as 10 and I is equal to 0. Initial value of I is 1. I should be less than 10 and I plus plus. This is the loop for generating only 10 Fibonacci numbers. And so we have the system.out.print line, and here all the lines all the result will be printed in the same line, and after following that line we have the Fibonacci generate I. This is the calling of the generate function again and again until the 10 loops is completed. So coming on to the initial point, we can see that this is the functional interface. Using functional interface, this is the line, functional interface line, and here this interface, this line, these lines. Yeah, this interface has only one abstract method. It has only one abstract method, generate n, and generate int n with the parameter n int n, and only one it has only one abstract method, so it qualifies to the functional interface. So it is a functional interface. And coming further, we can see that there is a Fibonacci generator. Here the class is function using functional interface, and we have the Fibonacci generator and Fibonacci. This is the Fibonacci type, Fibonacci generator type only. Where we have the lambda expression, where here we have the lambda expression to implement the interface, and here we have the parameter that is followed by the body part. The body part is an implementation of generator n. This body part shows that this is generator. This is a implementation of n. Generate n. This is a generate n. Yeah. Now coming further, we have the inside the lambda. We can see inside the lambda we can see that n this implies to the body part that will be returning a value that is equal to n, return b. So here we are giving the value of a as 0 and b as 1 and return n, else the value will be a as 1, a as 0 and b as 1, and this value, this line, if n less than equal to 1, return n. This line states that if directly if the value of n is not equal to, is not greater than 1, then the value will be again returned to n. Means the we have to again start from the entering point at n only. Now coming here, we have the value of a as 0 and b as 1, and and coming to that, coming further, we have the looping statement here, which has the body part. As I already explained that here the first the summation of a and b will take place, then the a value will be assigned to the value of b, and b value will be assigned with the summation value, that is the temp. Yeah, and then comes to the, after closing the loop, we will be again returning this value by b. Yeah, an alternative approach to calculate this is an alternative approach to calculate Fibonacci series to avoid recursion and improve performance. This is done to avoid recursion, to improve the performance. Now coming to the loop to print the Fibonacci series, this loop calls the generate method. This loop will call the generate method. This, yeah. Coming on to this loop, we have to come further coming here. We are seeing that there is a statement written here. Fibonacci series using functional interface, and coming further, we have this loop. Yeah, this loop will generate the Fibonacci numbers using the generate method. This loop calls the generate method to generate method for the value of 0 to 9. Using the loop, we will have the initial value of 0, and this loop will go up till 9. So this value will go from 0 to 9, and it will print the first 10 Fibonacci numbers. Now coming here, we are here. We can see very well get the outputs as here. Coming here, yeah, we can very well get the outputs of this method, this line, as Fibonacci series using functional interface is 0 to 1, 1 to 0, 1, 0, 1, 1, 2, 3, 4, 5, 3, 4, 3, and 5, and 8, 13, 21, 24, 34. These are first 10 Fibonacci numbers. Yeah, these are the first 10 Fibonacci numbers, and we have got to know how is this program is going on here also. For your part, I'm telling it again that this is a functional interface. In the beginning, we are declaring a functional interface having a single abstract method, having a parameter as int n. That is which we are inputting the value of this value as n. And if in this program, coming further in this program, this Fibonacci series is this is a lambda expression which is having value of n. This parameter is denoted to the body part, and if the body part is less than 1, then it will again ask the value to enter the value of n. And here the first value of a is 0 or b is 1. Here a is 0 and b is 1, and then we have the looping line here. Where the first where we are performing the summation of a and b, and then assigning the value to the temp, and then the value of a will be assigned with the value of b, and b will be assigned with the value of temp, and further the things will be done, and finally we will be returning the value of b. Yeah. So coming further, we have this looping statement. This looping statement we will be calling this generate method continuously. We will be calling this generate method for the 10 times. We will be calling this generate method for the 10 times to print the Fibonacci numbers from initial value to the end value. Yeah, to the prescribed number of times. This loop will go up to 10 times from 0 to 10, 0 to 9 only, and this loop will be printing 10 Fibonacci numbers, and the output will be seen here. So here we can see that this is the functional interface is allowing us to use pass logic using the lambdas. This functional interface is allowing us to pass logic using the lambda and this lambda expression. This lambda expression makes the code concise and avoids creating separate classes. This lambda expression will help us in providing shorter, concise program. And the functional Fibonacci logic. Here we have seen the Fibonacci logic easily encapsulated and reused using the interface program only. And at the rate of functional interface, this in the beginning line, in the beginning words, we see that at the rate of functional interface, we have this line. This ensures there's only one abstract method. This method will contain only one abstract method, and that is inside the interface. So this interface, Fibonacci generator is an interface and having one only abstract method. So that is generate and having the parameter as n. And Fibonacci generator. This Fibonacci generator. This is an interface. With generate and intent as the method. Generate and intent as the method, and lambda expression. This lambda expression is where the parameter is complies to the body part, where this parameter end applies to the body part, which is this. Yeah. Now coming further, we have the iterative function logic. We have the iterative function logic. Which can be seen by this loop method only. This iterative function logic, yeah. Fibonacci generator I. This is continuously calling the generated function. And loop in method I. This prints the 10 Fibonacci numbers, and this loop will print 10 Fibonacci numbers. And finally, we can see the returns the output as 0, 1, 1, 2, 3, 5, 8, 13, 21, 20, 34. These are all the first 10 Fibonacci numbers. So we can see that 0 and 1, which we have entered as initial values. The summation of both these values will be 1, 1, and then a value will be assigned by 1, and a value will be given to the 1. A value will become 1. Initially, the value of A was 0 and 1. Now the value of A will be 1, A value will be 1, and B as 1 only. B will be given as value as temp. That is equal to summation of 0 and 1. That is equal to summation of 0 and 1. That will be equal to 1. Yeah. Now again, coming forward, the A value will be given to 1, A value will be given to 1, and B value will be given to 2, and the summation of 1 and 2 will be 3. And further, same thing will be repeating again. So coming to the end, we end these chapters, we end this class. We'll meet in the next class. Thanks.